Hello and welcome to this talk about fingerprinting all the things with scanner. First, a few words about me. So I'm a security researcher in the R&D team at Kudelski Security. I focus mostly on network-related security research. Some say I do threat intel, but what I really do is port scanning and fingerprinting. I blog sometimes, code a lot. I'm a big fan of the command line interface and open source software. And here you can see like the terminal. This is where I spend most of my days. I wanted to have the black slides, but it wouldn't work out with the black terminal. So I had the light slides. So if you're here, if you can answer one of those questions by yes, this means you're in the right talk. If no, then stay a little bit longer. Maybe you'll like it. For example, are you interested to know all the versions of the DNS servers that are reachable on IPv4? Or match a specific pattern on all pages of, for example, the Alexa top 1 million top ranked websites? For example, to identify a specific CMS or a web server being used. Or even, do you want to know the SSH version that is used on your perimeter, for example? So these are all questions that can be answered using scanner. So hopefully, in the end, you'll use it and you'll be able to answer those questions. The agenda for today, first, I'm going to go through a little introduction on fingerprinting. What is it? What are the challenges and so on? The existing tools and what are their limitations. Why don't they scale, actually? Because they scale vertically. And why scaling horizontally is a better way of doing it. And then I'll introduce scannerl and do a little summary. Yes. So first, let's start with fingerprinting. But first, I guess you're not all aware of the difference between port scanning and fingerprinting, so I'll do a small recap. Port scanning is simply the process of trying to identify the status of a port. Is it open? Is it closed? So usually you send a packet with a specific flag, here SYN, and you monitor the response. If it's a SYN ACK, you know it's open. If it's reset ACK, it's closed. If you get nothing, then either you get lost, it's firewalls, or other reason. So port scanning is straightforward, pretty linear. But service printing, in the other way, it goes much beyond. So instead of targeting of wanting to know the status of a port, you want to interact with the server. So you want to interact with the service that is running behind that port. So you have to do multiple exchanges to do that. On the right side, I know it's too small, that's not the idea to read it, but this is a SSH connection establishment. So as you can see, there's much more efforts to communicate with the servers. The green rectangle there is simply the part that is doing the port scanning. So fingerprinting goes way beyond. So you have to be able to understand the protocol and talk with the service in a way that provides you the information you're looking for. So like I said, it's more complex. You have to understand the protocol. It's a much longer process depending on the service that you're targeting. And in the end, you don't get like a status. Is it open? Is it closed? But you get the whole payload that is being sent by the remote service. And since this is a payload that you'll have to parse, you have to handle some unexpected data, because it won't be a single packet with a flag being, okay, this is open, but it will be the whole exchanges. Now, even more, if you consider running it on millions of targets, it will be a very long process. It might also impact the network, as those poor guys here. And you'll have to answer questions like, how do I handle the whole data set in the end? How do I parse those data? How do I store that? And you have to be fast and efficient, because if it takes like weeks to do millions of targets, this won't work, as we'll see. We will see. So a few words on the different tools that exist and their limitation. The first idea for fingerprinting is to do it by scripting. exist multiple tools for doing that. One of them is Scapy, a Python library that allows you to forge packets and in order to produce an exchange with a remote host, or also hping, which is a Unix tool that also allows by providing specific payloads to interact with the service you want to fingerprint. For the most power user, there's always Netcat, but I guess it's not very efficient. So all those tools give you a lot of power, but it's tedious and very specific. If you've done the implementation for a specific service fingerprinting with Scapy, for example, you'll have to start over again for another one again and again. This is my favorite slides. I've put it here because I found this is the most elegant way of doing fingerprinting. I was looking to have some smile. Yeah, there's some smile there. So I'll go through it. This is just the geeky way of doing it. The idea is you declare your target, so the host and the port there. You open a socket with a specific device on Unix file system, and then you use Unix tools like Echo and Cat in order to send your payload and receive the response. It's pretty elegant, but of course, this is not very efficient. But I had to put it because I really like that solution. So another solution is to use tools. There's plenty of existing tools for doing that, one of them being Nmap, and it's NSC scripting engine that uses Lua programming language in the backend. And it has a pool of scripts that are available to fingerprint a lot of services. So this is a very good tool. zgrap, on the other hand, is made by the ZMAP team, which is also a tool. It's growing, getting more and more service available in it. There's SSH, HTTP, and all those most used services around. So those tools are pretty flexible and very complete, but do they scale, and how fast are they? So I've done a small test on the Alexa top 1 million websites. So this is the 1 million top ranked websites on internet. And I use a pretty decent machine, so 24 CPUs, 190 gigs of RAM, and 1 gig pipe. I've had tweaked the server in order to be able to process that many packets. So zgrap did it in like 48 minutes, which is pretty good, I would say. Nmap, to be honest, after 14 hours waiting, I cancel it. It was only done at 8%, so yeah, not a great success. And like the picture says, I'll almost die waiting. Yeah. So yeah, just a few words. 48 minutes, you could say, okay, this is pretty decent. This is fast enough for me. Yeah, but that's only 1 million. If I say that there's 80 million opened HTTP port on internet, doing that with zgrap will take you 3 days. This is not very efficient, and there's probably other solutions to go much faster than that. So how do those tools scale? The only solution is to scale vertically. By vertically, that means you'll improve the hardware. You'll get a better CPU, you'll get more RAMs, you had a better network card, and so on. It all depends on the bottleneck that you're hitting. If you're hitting a bottleneck on the CPU, then you improve your CPU. This is all nice, but at some point you'll hit a limit. You won't be able to scale indefinitely on the same machines. Also, scaling vertically, so adding a better hardware on the single machine, has also drawbacks. You'll be limited by the routing devices on the path to the target, like those poor ships there. For the back, this is ships. So the idea is that you will be sending from a single host all your packets. So if it passes through a device that has a smaller pipe than yours, then you'll be blocked there. Also, you're using a single IP, so you might get blacklisted by your ISP or any other instances out there that are not happy with seeing all those packets coming from your single IP. This is also a single point of failure. If your host crash or get blocked, then you lose all your results or part of it. And it's also expensive. Having machines with 24 CPUs and that many RAMs is a lot, but even scaling even more than that is also a lot. So now we get, so why is scaling horizontally a better solution? By scaling horizontally, this means simply getting your own army of minions and distributing all your little tasks to them so that all those little minions will process your task. This uses the cloud, and it's nowadays pretty cheap to have VMs, so this looks like a pretty good idea. Also, it has specific advantages, like it's stealthier. Since you're having multiple minions, you have multiple IPs, you're then less likely to be blacklisted since all your packets will go from different paths. It's also fair because you won't hit the same router on your path to your targets, but multiple ones. It's resilient. One of your minions die, then you only lose part of your results, but the rest keeps on doing, and should be faster. By adding more minions, you get faster, and your scan takes less time. But distributing an application, so with minions, with VMs, brings also its own issue. If you've ever played with multi-threaded application and locks and mutex and so on, and you apply that to distributed application, then you know it's a big mess and a nightmare. Also, how do you handle the communication between all those little minions? You have to answer a question like, how do I distribute the task? How do I handle failures in case one of your minions die and you have to restart it? Or how do you do that? And in the end, you'll have all those minions with the results. How do you aggregate those results at the same place in the end system? So that's where Erlang comes to the rescue. I don't know if anyone is familiar with Erlang, but it's a pretty good programming language. It has concurrency available out of the box. It provides distributed application, and it uses a nice mechanism, which is message passing for communication. So instead of using locks, for example, it uses mailboxes that buffer the message being sent. So you get the master node, for example, that would send message to all the minions, and those messages get buffered into the mailbox, and each process is able to just check when he wants or when he is able to get the message and process it. So this is a very good system in order to avoid all those issues with distributed app. Also, it uses the actor model. I'll go deeper in that in the next slide. It's resilient, so the idea is, you know, one of your minion might crash, so be prepared for that and set up all the different stuff that you need in order to keep on scanning and keep on doing what you're doing. Also, scannerl has very small processes. We don't call them processes, more Erlang processes, but it's 300 words. So that's pretty small. It means that you can have more than 100,000 processes on a single host. So that sounds good for fingerprinting, for example. What is this actor model? So like in object-oriented programming, where everything is an object, here everything is an actor, like this nice guy here. So each process is isolated from the rest. It has its own mailbox and receives all the message through it and process the message as long as it's alive. And all this make it a very good model. So Erlang is based on that model, which makes it a really good and powerful programming language. Now, how do we apply that to fingerprinting? So let's say that each target, so in each, for example, of those 1 million top rank website is a minion, so is an actor. You would spin a new Erlang process for each of those target. Each process will communicate with the remote host, so establishing the TCP connection, sending the payload, receiving the payload, and at the end return the results and die. And another one will be spin for the next target. So this sounds pretty good, and I guess you see where I'm going. So this is where I'm going to introduce scannerl, which is based on all those little principles. So you're still here, guys, right? That was the boring part. Now comes the fun part. So here is the design of scannerl. So on the left side here, you get the master. This is the part that is doing all the tedious tasks like parsing the arguments, getting the targets, starting the different nodes here, and so on, all those boring tasks. The broker is the part that is running on the VM. So this is the part that receives a list of targets and will spin new processes for each of those targets. And at the end, we get those actors that are actually one actor per target. So that means that the broker, if it receives 1 million targets, it will spin 1 million process. So the design is pretty good because it allows to scale a lot. Also, all this process of creating the broker and communicating with it is all transparent to the user. So all you have is your host with scannerl running on it and access to some VMs, 10, 100 VMs, and all the process of creating the brokers, sending the target to them, and then spinning the different actors is all transparent. You don't have to do anything. So of course, this allows for infinite scaling. Yeah, that's me being a little bit optimistic, but the idea is that you're able to decide the number of broker you want, so the number of VMs, you provide it to scannerl, and then you decide the number of actors or long processes you want per broker, and you get the whole process going, and you should be able to scale indefinitely. So this is all good and nice, so the design looks good, but fingerprinting, like I said at the beginning, is specific to the protocol, to the service that you want to access and communicate with. So the core provides all those basic blocks of parsing, starting the VM on the remote host, and so on. And we've added two modular elements, the fingerprinting module and the output modules, that are easy to integrate into scannerl. The fingerprinting modules is the part that is running on the actor pal. So that's the little minions that's communicating with the servers. And the output modules is the way you want your results to be filtered or aggregate or parsed before they get outputted to any kind of output. So I'll go a little bit deeper in those two modules to give you an idea how it is, and it's not that difficult. So the fingerprinting modules is actually allows you to perform three types of communication: TCP, UDP, and SSL. Sounds pretty good so far. And there's a mechanism of callback so that actually the whole scanner process here on the left will be handling all that is the transport communication, so establishing the TCP connection or sending some payload, receiving some. And your module on the right side, we only have to respond what is the next step to do. So for example, after the connection is made, the scanner will ask your module, so what I do next? And you will provide some payload that will be sent to the remote host. And then when the response comes back, you get to parsing, and so on and so forth until you're happy and you bring back some results. So this allows for easily implement some modules without going into whole the network layer stuff that is sometimes a bit more difficult. So this is how it looks like. If you've never seen functional programming or Erlang, bear with me. I'll explain that. It's pretty easy. So like I said, you have to declare the type. So the type, you can change it in one line. So for example, if you implement a module for TCP, like for HTTP, for example, and you want it to be applied to HTTPS, you will just change the TCP in SSL. So this is pretty convenient. Also, as it's functional programming, the same function will be entered depending on the argument. So this is the same different steps we've seen in the graph before. So the first function here, we enter when we start. So when the connection has just been established with the remote host. And here, you'll provide some payload in return. So this is what will be sent to the remote host. The second one enters if nothing's come back. For example, the remote host has an answer or is not running the service we expect it to be running. So here you would return some kind of error like a timeout, for example. And the last part is where the interesting stuff is going on. So this is where you get your response. You get to parse that and format that in the way you want. So depending on what you're looking for, and the results that you put here will be sent back up to the master node, which will aggregate all those results. So as you can see, this is a simplified example, but it gives you an idea how easy it is to just implement a bare module for fingerprinting a specific service, for example. The output module is based on the same idea with a callback. It has also two functions, ini and clean, in order to set up and manage the output. Let's say, for example, you want to write to a file. In the ini, you will set up your file descriptor so that it's ready to be processed. And in the clean, you will close the file descriptor or flush the data to the file. And this way of doing allows to format or even filter or reformat the data the way you want it. For example, you could want to output that to standard out, like print that to the console, save to a file, even push to a database or stream to another host. So anything is possible here since you have control over all results that are provided back by the fingerprinting module. This is how it looks like. So ini and clean, this is just an example. It's pretty straightforward. But the output here is where each results will go through before getting outputted. So here it's simply writing to standard out, but you could think of, for example, sending to some Elasticsearch node, for example, for post-processing, or save to a database, SQL database, or whatever. Anything is possible, and this freedom allows to pre-process, so to say, the results so that they're formatted the way you want it in the end. So how does it look in practice? Here, before I'm going into how fast is it, how good is it, so a few lessons learned about using a scanner. First, fingerprinting, like we've seen at the beginning, will bring back a lot of data, not only the status of a port like port scanning, but the whole payload that you're asking the remote host. So since Erlang is running in the virtual machines, you sometimes end up with a heap overflow. So you'll have to increase the RAM. We've also added a few options in order to control that, but you have to be aware that this is something that could happen. Also, the bottleneck is not how we would think in the actor side, so the side where we connect to the remote host, but more on the saving process. So it means that it's not always the perfect solution to add more minions to process more faster the targets, but more how do you handle those results? How do you save those results, for example, to a file? It's also pretty difficult to debug a distributed application. If you've done that, you know what I mean. Internal communication will impact your network too. So not only the communication with the remote host, like the service you're trying to fingerprinting, but all those retrieving the results back, managing all your nodes, and so on. And like I said before, everything is transparent, but you still have to provide VMs for scannerl to use. So you have to set up those VMs. The dependencies are not high. It's only setting up a few options for Erlang and installing Erlang, but still you'll have to set up those VMs. You can use any deployment tools like Ansible, for example, to do that, but it has to be done in anywhere. One thing you have to do when using scannerl too is to give a lot of love to your sysadmins, because using a tool like that scales pretty large, will impact your network and will most likely break it. Here we can see a contract table on a firewall being hit. So once the contract table is hit, then you don't have much more going on, right? So I don't know if my sysadmins are here, but anyway, if they are, thank you guys. Because I broke their network a few times and they've been really nice. So yeah, you have to be aware of that. It will create a lot of parallel connections and might or will break your network. So now we get to the performances. So I took the same target as before. So Alexa top 1 million top rank websites. I tried to be fair, although the comparison is not very fair between a distributed application and standalone application, but still I use 20 VMs, each with 1 vCPU and 2 gigs of RAM against those 24 CPUs and 190 gig of RAMs. Anyway, so zgrab done it in 48 minutes. Nmap wasn't done, and scannerl was done in 4 minutes. So this is a 10 factor. It's pretty nice, and we've only used 20 VM. So what if you scale even more? So I've tried with 60 VMs, and we come down to 1 minute and 30 seconds. So this means that here, like I said at the beginning, if you want to target all those 80 million targets, like zgrab would take 3 days to do that. Here with scannerl, you do it in 2 hours. With 30 VMs. If you double the number of VMs, then it gets probably down to 1 hour. So this is pretty good. As you can see, we've tried several protocols. Of course, all that is SSL related, where you have more overhead of due to the communication. It's a bit longer, but still you can scale. And the idea is that you should be able to add more VMs in order to be more performant. So yeah, pretty good results. So now you say, so how much does that cost? Well, it's free, like in free beer, although it's a bit early. But it's open source on GitHub, and there's already a few modules available there. But we're releasing more, especially related to ICS and SCADA. So if you haven't yet, go have a look, clone the repository, try to play with the tools and see how it works out with you, for you. And if there's anything not working, feel free to open an issue or come discuss with me. We are happy if people try using it because I think it's a great tool. So what are we gonna do next? First idea is to package for big Linux distribution, like Kali, for example, for pen testing, Ubuntu. We've seen it, it's already a package for Arch Linux, which is pretty good. I haven't done it, so I found out the other day, so that's nice. We want to increase the pool of available modules by getting the community involved. The idea is to get more of those modules being implemented. I'll have to improve the documentation. It's not the perfect task and not the most interesting one, but I have to do that too. One of my wish would be to port it to IPv6. It's not on the plan, and I don't know if we'll do it, but I think it will be a great challenge, and especially since everything is moving towards IPv6 today, this is a kind of tool by using scaling that could allow to do large research on IPv6. And of course, get a fancy logo. So if you have any idea, come talk to me. I was thinking of a skull or something, but I guess marketing won't agree. So we'll see. So a little summary. So scannerl is fast, as I've shown, because it's distributed. It's flexible, so you're able to implement your own fingerprinting module and your output modules to handle the results how you want it to be. It's open source, so it's free. You can get it as it is. It handles TCP, UDP, and SSL, and is able to target IPs or even domains, so independently of both. And it has very few dependencies because only Erlang is required to run it. So, yeah. So that's it for me. I was fast, I think. I've put the link to our GitHub if you want to try the project, and to our blog where we publish some of our results if you want to go have a look. And yeah, thank you for your attention, and don't ask tough questions.
Any question?
Did you try to run it in a cloud? And do you know some cloud providers that allow you to spin up some VMs and do scanning?
Yeah, I tried. It wasn't very successful because I got a lot of abuse. Yeah, usually cloud providers don't like all those activities of scanning and so on. So you have to check all those little chars at the end of what you signed or what you register for before doing so. I tried. It wasn't a success because I got blocked. But I got a nice slide for that. You can. Whoa. Okay. I'm sorry, I'm not a Windows user. Okay, I'll go fast through that. You can build your own cloud, and that is by simply getting Raspberry Pis. And you could run scanners on different Raspberry Pis in a rack, for example, and you get your own cloud, right? Since you're able to control the number of process. Yeah, bulletproof hosting, yeah, definitely.
All right. Any other question?
You were talking about TCP pooling. Are you using anything similar to Cowboy or something like that?
To what? I'm sorry.
To Cowboy.
To Cowboy.
Which is one very well known, TCP pooling tool for TCP.
Okay, I'm sorry.
Similar also to Mosha Web or something like that. Yeah.
No, I don't know that.
Nothing. No. Yeah, it's well-known things in Erlang. So.
What is it? The vulnerability scanner?
No. It's not a vulnerability. I'm talking about just the part of a TCP layer. Why you have to rebuild everything because there is still things already developed. So in terms of Erlang, there is a lot of things done in terms of TCP.
Oh, okay. I see.
This is why I'm asking the questions. For me, it's exactly 100 similar in the backend, like when you are, for example, using actors or you are scanning to for example, the HTTP connections, like
this abstraction layer that I was talking about.
Yeah.
No, I've never used it and didn't even know. I'll give it a look. Thank you for the pointer.
Cowboy, it's
okay, cool.
Okay,
nice.
Cool.
Thank you. Thanks. So, if I remember, there was another question here.
No demo. I don't want to break the cloud, right?
Yeah. Yeah, in fact, I have two questions. First question is, did you give a try to Mascan? Just to understand.
Not for this test. I've tested Mascan in the past, not here. But Mascan, as far as I know, you can provide a payload for fingerprinting. It does mostly port scanning.
Sure. The question was to understand if you gave a try and why you didn't reuse the tool.
Okay. The thing is, Mascan for me is mostly oriented to port scanning and not fingerprinting. And so this is the whole idea I had with scripting. If you have to always provide the whole payload and stuff and do some geeky stuff around that and script the whole thing, then if even after that you're not able to scale, what's the point of that? So this is the whole idea of scannerl, is to try to scale horizontally, so distribute it on minions and in the cloud.
And my last question, it was just to be sure that I understood. When you mentioned that you launch an actor every time you have a target, for example, if you want to scan like 65K ports, are you able to launch an actor for each port? I'm asking this because you mentioned blacklisting, and I think it might be interesting to have many actors in order not to be blacklisted. I don't know if you have this granularity.
Yes. So you can choose the number of, there was a slide for that. You can choose the number of brokers, so that means the number of VMs. So you can think of a broker like a process on a VM, or you can even think multiple broker on single VM. And then for each broker, you can choose the number of actors is spinning. For example, if you say, okay, I want just only 100 parallel processes or fingerprinting processes running, then you can provide that as an option. And you can also not limit it, but the thing is then you'll break some networks like I've shown before. But yeah, you have that granularity, and that's all options you have when launching the tool. Yep.
Okay, any question left? There is one.
Actually, just a little question. So everyone is laughing because we are working together. Just a little question. Did you try to run it on the big ass machine to see how good it compares on a single node compared to the other tools you compared?
That's a good question. So I haven't directly on this machine there, but the thing is I've done is I've experimented that using multiple brokers on a single VM or single machine is usually not good for performance. It was better to have a single broker and double the actor instead of doubling the broker and having that separated in the two process. So that's from my experience. I haven't tested on that machines, but yeah, you should definitely use one broker per VM.
Okay. Last question.
Well, actually, there are like 3 questions. First, do you have any result that you can show of about, for example, the fingerprinting that you have done? The second one is that have you been detected as a DOS generator or something like this? And the third one, have you been contacted by Shodan or any other fingerprinting searcher for using your stuff?
Okay, so first question, yeah, we provide our results in this blog. Maybe it's too low. I got like a full page here. So yeah, if we publish something, it's all there. Go have a look. We publish a lot of our results. That was for the first question. Second one, yeah, of course we get abuse letters. This is something we're used to because when you perform port scanning or fingerprinting, people get angry. So yeah, we do that, and we usually answer personally to each person that has requested us to stop or that is not happy with what we do. And last question was... Oh, Shodan. No, we haven't been contacted by Shodan or any of those scanning platforms.
Okay. Thank you, Adrien.
Thank you.